I'm Karen. I'm a member of technical staff at Anthropic. I'm on the Claude team, specifically working on evaluation systems and multi-agent architecture. I'll probably be referencing from my notes a lot today because I'm really bad at memorizing things, and Claude just memorizing everything for me. So I want to spend the next few minutes talking about like something I think about constantly. What does it actually mean to design the interface these days when we're actually interacting with agents a lot? And the agent architecture really matters a lot more than like in the past. And here's the main thing I want to share with you today for the session. So when you're building with Claude Code, I know a lot of you guys are already experts on Claude Code, but I also want to share more about like the workflows that we use every day on the team. I want you to like maybe shift your mindset a little bit because you're not really configuring a chatbot. You're actually writing the rules of an agent's world, what it sees, what it can do, what kind of tools it can use, and when is a good time to stop or like ask for feedback. And it's a fundamentally different design problems, which means like you're switching from like drawing boxes, specifying flows, testing with actual like human beings. Like the mental model was really in the past, it was like a human sees something, reacts to something, and then clicks something. But the model doesn't apply to this kind of model doesn't apply to Claude Code anymore. The agent can't really click, but instead of like designing screens, we're actually designing three things that I'm going to mention next. I think it's really about constraints, what the agent is allowed to do, context, what does the agent know, each individual agent or like sub-agents in a multi-agent system, and then interaction loop, how does the agent get feedback from either human or other agents and improve itself interactively. And then everything in this talk flows from this kind of reframe. There are models on the left and then new models on the right. I think we could try to like consciously move to the right column and how you think about building. So what actually changed with Claude Code and why is this conversation happening now? I think there are three things. First, the terminal is now the interface. Claude Code lives in your shell, your editor, your CI pipeline. There's no GUI wrapper, so which means the interaction primitives are pretty different. You're not designing like button states. You're trying to ask like an agent to help you accelerate everything, and then designing like command services essentially. And then next, I think is the agentic loop, which is a really like it's a huge productivity boost for me at least. When there are like multiple, especially with the multi-agent system, in Claude Code reads files, writes code, observes the output and iterates. It takes multiple turns, and it's so much faster than a human being if you use it with like multiple agents at the same time. So it's not just a single exchange, and I'm gonna mention it later on, but if you have orchestrators delegating to specialist sub-agents to help you do the design work or UI work, it would just leave you with like so much more time to think about the high-level architecture and everything, and the decision you're actually making will be like so much more like high-level instead of like the actual implementation work. So. And then if we accept that the design space is shifted, what are the actual building blocks? I think like one is the constraint. And in terms of, in the like the context of Claude Code, what can the agent do? This is like your permission model, your tool scopes, your file system boundaries. And then constraints sounds like, really sounds like limitation at first, but they're actually enabling. I felt this a lot on my team working on Claude Code. So an agent with like well-defined constraints and actually move faster, and like it will have like its own like specialized scope, and it won't have all the risks that you worry about. So you actually like enable greater capabilities for each agent. And then the context is what does the agent know? This includes a lot of content in the claude.md file, and also like your own memory injection patterns, how you index your code base, what state you're maintaining across sessions. I, I personally think context is the most underinvested areas I see in terms of building with Claude Code, and you could potentially unlock a lot of new capabilities if you manage your context well enough, or like just use it carefully. There's this like usage for like context / command in Claude Code that you can like constantly check to like get a scan of your memory and your context. And then the third primitive is the interaction loops. How does the agent learn and improve from designing the interface? So you can think of like checkpoints, error recovery, human in the loop triggers, feedback collection. I think this is the more dynamic layer where things go wrong and where you can like course correct on time. And then I'm gonna spin a slide on each of these primitives. So let's talk about context first. Claude.md, I think a lot of you guys are probably already aware. It's a file that lives in your project root and gets injected as a persistent context at the start of every Claude Code session. You can think of it as the closest thing to a system prompt that you have for agentic work. But most teams treat it as a README, but it's actually not. It's really your design canvas. And what does the agent need to know to behave correctly in your code base? I think this is the question you want to think about before you start implementing things. Not just like, oh, here's what this project does, but more like, what tools should it prefer? What kind of directories should it never touch? What conversation, what like code conventions should it follow? And this all goes into like your Claude.md file. And then, like, I guess this is like a really simple example on the screen. If you notice, like the structure, project context tells the agent what kind of like code base it's in, and then agent behavior defines explicit guardrails. For example, like never modify, or like run tests before every commit, ask before deleting files, and then there's code conventions which defines patterns that would otherwise require the agent to infer from examples. So I guess like my strong recommendation is just to treat Claude.md file like an RFC maybe, version control it, review changes to it, update it when your agent starts making new classes of mistakes or start having like new kinds of behaviors. And then it should really be like a living document that encodes your team's accumulated knowledge about how to work with agents like effectively. And I guess in terms of constraints, like I mentioned, most people would think this is like restrictions, but like I think it's actually what let you give the agent more autonomy. Eventually, if you know the agent can only write to like your source directories and will always behave as instructed, then you're essentially trusting the agent more to buys it more freedom to do stuff. And then there are like maybe 4 layers you can think about to scope. So do you have separate tool sets for production versus development, or is there separate tools, or is there like explicit allow or deny list? And it should be like the rule of thumb is like everything should be really explicit instead of like implied. by the agent. And then the file system is the agent restricted to the project root. Do you really like separate source from test, or yes. And then in terms of execution, examples would be like, are you sandboxing bash by default? Or are you limiting external calls? Are you setting like timeout or fallbacks on long runs? And then confirmations, in terms of confirmation, where do you really require explicit human sign off? In terms of like I guess designing UI, where is the good time to like step in and then make decisions on behalf of agents? And then I think the key pieces here are like actually the interaction, like iteration loops instead of the individual steps. This is where where our team usually see the biggest gap between like power users and like regular users. Like if you look at the diagram, an agent loop has like 4 phases: perceive, plan, act, and observe, and you need to take care of all of it. And then in the perspective of a graph, like you want to design the whole system instead of just give like a simple prompt and then wish that Claude Code can do everything for you. So your interface doesn't really live in any one of those boxes. It really lives in almost like the feedback loop between them. Every decision you make about what the agent surface is, what it logs, what it asks about, those are all like interaction loop decisions. Yeah, and then I guess in terms of tips, maybe like surface checkpoints for natural loop boundaries. Don't just interrupt the agent on every step, and then interrupt at like meaningful phase transitions, or like compact your conversation at meaningful like turn points instead of like in the middle of something. And then give the agent a way to like signal uncertainty. Like you want to like give agent the ability to like escalate to a human, like when there's like failures or like uncertainties, and if the agent doesn't know how to proceed or whether to proceed, it's always nice to ask for permission or like human intervention. And then design for recovery. So I guess we always want to think about like when what happens if this like action fails. Does the agent retry, surface the error, or like roll back? I feel like most teams put all their efforts into like the happy paths, but the retries, the timeouts are actually like more annoying than ever. And then last thing, I would suggest to like maybe log everything or just capture the data along the way. For every like loop iteration, or for every because you really need this for like keep iterating on your own product for like closing the loop, and also for evals, because I work on evals a lot. I think it's really helpful to just turn the user feedback, or like turn every piece of data you can gather into something that the model could be using to improve itself. And then I guess like what we're actually seeing from people who use Claude Code, this is where I want to ground this in like reality for a second. This is what we are noticing from a lot of users. So pattern 1 is like context front loading. A lot of power users will paste like documentations, architecture diagrams, and specs before they like issue any command or like start doing things. We also use plan mode a lot on the Claude Code team. I think it's one of the most powerful things. Like you align with the agent, the executing like the execution plan before proceeding. It's way easier than like course correcting in the middle of something. And they're like, we want to treat Claude Code like a briefing. You have to bring the agent up to speed, give it enough context before you can send it on a mission, instead of like maybe the second pattern, lazy instruction. So like big tasks really just produce really expensive rework loops. For example, like if you ask agent to like just clean up this code or like write this, polish this UI for me, it will never know like what exactly it means without any specifics. And like the outputs will usually be like technically correct, but it will miss what you actually want. And then the number one failure mode is really like the agent making mistakes. It's often we, the users, not specifying enough or not giving enough context for the agent to succeed. So a lot of times it's actually not like Claude like hallucinating. And then the third pattern is the checkpoint anxiety. When a lot of users, when they don't understand what the agent is doing, they interrupt it constantly, even when it's doing the right thing. I think we also want to improve this from our part. We want to give more like transparency about the agent state, and like you also want to expose it to your service as well. Like it's really important for like adoption and like yeah, and then and you want to have an agent that explains itself, like and gets interrupted less often, for sure. And then the fourth pattern is like in-session feedback signals. Users know when something's wrong and when the agent is being lazy or over-engineering or like going in the wrong direction. You want to give them your end user a way to signal that mid-session, and then you also get like incredibly valuable data to iterate on the product. And then this is like one of the topics that I'm really excited about because I work on like agent swarms, and I always feel like this is like one of the most API things. Like you might not be building like swarms today, but I think you should be like designing like you will. Here's a good pattern. So an orchestrator agent breaks a complex task, maybe it's a design task or something else, into like different subtasks. The orchestrator itself doesn't have to like execute anything. It could just be responsible for like breaking down tasks into like individual pieces, or like assigning group members for tasks and like collecting task status, and reassigning if needed. And then at a lower level, there could be like multiple sub-agents for like multiple agents with different like context window. They could be responsible for like specialized capabilities like search, coding, or testing or reviewing. I think it's really important to isolate the context. So the sub-agents, because they are responsible for completely different things, like if they're responsible for completely different things, they don't have to share state implicitly, and they could have their own context window if needed. But if they're working on like the same thing together, then it doesn't make sense to isolate context. And then on the orchestrator level, it must like reconcile conflicting outputs and then aggregate all the results, and then it's also responsible for like the final output, whether it's like a website front end or like a back end or anything, honestly. And then you also want to think about when, let's say, one sub-agent crashes, was the backup plan, or is the task like reassigned to like someone else on the team? So it's really about like you thinking yourself as like a team lead, and then you delegating work to everyone else. Yeah, and then in terms of observability, you want the orchestrator or maybe like every agent on the team to know what everyone else does. It's about like giving visibility and then updating, almost like a message system. Yeah, and then I guess like here's a to-do list you might want to consider. Um, to maybe make your Claude code more effective, really just write your Claude.md today, not like someday. I feel like even a rough draft is better than nothing. You want to be clear about like, you want to be clear about like what you're expecting from Claude code, and then really treat it like a living spec. Claude.md is also hierarchical, so you can have multiple Claude.md in your directories and subdirectories, and then it will respect the hierarchy. So maybe put the high-level instructions at the high level, within the high level Claude.md, and then lower level you can specify, let's say, code conventions for a specific repo or instructions or commands you want to run for that repo. And then also like define two permission layers, tiers. Like for example, what should be like read only, what should be like read write, and what requires human approval. Just write it down and get an understanding of like how much permission you want to give each agent, or like each Claude code session. And then maybe set up like session logins just for future use if you're like expanding to end users, because that will help you like iterate, and that will also give a lot of information for your Claude to help you iterate on the stuff. And then maybe build a session feedback mechanism, give users a way to like, or yourself a way to flag that outputs and make it like as frictionless as possible. And then I guess the eval remix is like less important than the rest skip, but maybe add checkpoints before like disruptive operations. Like maybe add like hooks to like Claude code. I think there's like multiple ways you can customize Claude code, but just make sure that it doesn't over-engineer or like do the things that you don't expect it to do. Especially that now we have Ralph loop, and there's a lot of different versions of Ralph loops. You want to make it as autonomous as possible, but also as safe as possible. That's also the state that we want to reach the Claude code team. And then you might also want to test with adversarial prompts. Maybe give the agent like intentionally vague or contradictory instruction and see what it does. More like a test, so you might learn new things out of it. And then try to measure like hallucination rate and try to define what it means to hallucinate. Because a lot of times I think this is like a word that we use it too often. Like if it's the case that you give the model enough context already and it's actually supposed to do the things you expect it to, but it's not, then it could be considered like hallucinating. But you want to make sure that you're doing your part first. And then also like document your agent's failure modes. Just build maybe like a failure catalog and share with your team. And then last, I would encourage everyone to maybe build a Swarm prototype like when you're free, because I just think it's really interesting. Like we built this prototype back then where like each agent talks to each other about like philosophy, and we just like observed all of them like chatting at the same time in a room. It's just fun to watch, and feels really like AGI. Yeah. Yeah, and then, but like one downside or like one thing maybe you want to take note is that Swarm costs a lot of tokens, so you want to maybe like consider the task that you actually want to use Swarm with. Like maybe for long horizon tasks or for like really complex things like rewriting the whole code base where refactor this huge piece of architecture. But for most of the tasks, I would say like you probably don't need like 5 agents working at the same time. But maybe for like larger tasks, you could start with plan mode, and then make sure that like each agent is like you're aligned with what each agent is gonna do. And then after that, delegating to multiple agents. I think it's a more organized way of like, instead of like just having a swarm without knowing anything under the hood. And maybe start with 2 layers, just the orchestrator and like a few sub agents. I think that's the easier way to get things started. But like if you're more comfortable, you can also try with like random graphs among the agents. But I think that's definitely like less within your control. So you might be surprised about the result. Yeah, and then just don't wait for the perfect architecture. Just like ship eval or like gather user feedback and then iterate. I think the agent interface is always going to be in beta. Like it's never going to be ready, and especially given how fast our model evolves, like you will also need to like upgrade or like get used to like how the new model is good at or is not so great at. Yeah, so I guess like to bring it home, like constraints, context loops, that's like really the whole design space, and then everything else is like a variation on one of those 3. And then Claude.md is really your most leveraged file. And then like I guess like if you're designing an agent, our users really want transparency more than they want autonomy. So maybe take that into like consideration as well to like show your work more often, and then maybe show the like especially the progress. Yeah, and then multi-agent is really within reach. So maybe design for it now so you're not like on our Cloud team, we always talk about like we want to design the UI, the interface, the form factor to fit into the model like 6 months later instead of like the model today, because we know that the model is just gonna get better. So you want to design whether it's your backend architecture or your front end UI to just be like forward looking. Yeah. And then I guess you all are building great stuff this weekend that will like run on agents, be built by agents, or even be validated by agents. So maybe think about the constraints you're setting, the context you're injecting, and like the agent loops that you're creating. Yeah, thank you.
Hi. I have 2 questions. So my first question is about your agents.md or your Claude.md file. Is there one thing that you keep across all of your Claude.md files that you've seen improve your performance in Claude?
Because I work on the code behavioral side of things, so I always have this instruction to like capitalize instruction to ask like my Claude not to like over-engineer, not like to be at the right balance between laziness and like over-engineering. And there's a lot of behavioral things I emphasize in my Claude.md. Yeah, but it's different across individuals.
Okay. And then I have another question. So all these hacks and all these things to improve the performance of the models currently, you're doing like not without changing the model, right? Do you think like something like Opus 4.6 can perform as good as something like Sonnet 4.6 if you add all these features and things to Sonnet 4.6 and just leave Opus 4.6 at the same level?
Good question. I do think the model is the most important thing. And I think the model is maybe what Anthropic thinks is the most important thing. That's why we always invest so much energy and time into model development. Cloud code itself is important too. It's like an abstraction layer on top of the model. But I do think it's if the model is not good enough, then there's a fundamental limitation.
Thank you.